Hello and welcome to this presentation on insolation and climate. Along with this presentation, there is a PDF called Insolation Notes that has pictures of similar slides that you can use to follow along and take notes as we go. So let's get started. To start us off, let's talk about what's the difference between weather and climate. What is weather? These pictures on the bottom might give you some ideas. Weather includes what's happening in the atmosphere here and now. So in a specific location at a specific time. Is it sunny? Is it raining? Is it windy? Is it foggy? These things all include weather. You can see the weather on the news. It will often include information about current conditions like precipitation, humidity, wind or air pressure, and the temperature and whether it's cloudy or sunny. Climate, on the other hand, we usually think of a larger region. Do you know what the climate is in these regions? I hope you guessed desert. What about these? These are the cold Arctic regions. And these are some of the tropical jungle regions of our planet. So climate is the average conditions of the atmosphere over long periods of time. With climate, we talk about average conditions over a long period of time, but also usually over a larger area as well. So let's take a look at some examples. Oh wait, before that, let's talk about how you measure climate. With climate, we can use weather averages for, say, the last 30 years. We don't have weather information going way far back, so we have other tools that we use to study this. For example, we use ice cores to measure the gases trapped in the ice to determine past temperatures. We can also look at tree ring data, and this helps us measure the availability of water in the past. Lastly, we can look at the fossil record. This estimates the past climate based on the type of species. If we see tropical plants and animals, we can guess that that area used to be tropical. And then to predict the future, we use computer models. We use these to predict climate change based on the current data we have and data from the past. So let's have a little quiz. If I say it will be hot in Provo this week, is that climate or weather? All right, let's go to the next one. The storm blew away our trampoline. What is this?
Weather.
It rains every day in the rainforest.
Climate.
July is Utah's hottest month.
Climate.
30 years ago it snowed in June and froze my garden.
Weather.
Mars often has extreme dust storms.
Climate.
I hope you got those right. Now that we know the difference between weather and climate, we're going to talk about how insolation and latitude affect climate. Let's move on to the top right box on page 1 of your notes. What is insolation? Insolation is incoming solar radiation. Insolation may be transmitted, absorbed, or reflected or scattered before reaching Earth's surface. This image shows a picture of the Earth's energy budget. Energy that comes from the sun, or insolation, can either be reflected or absorbed by the atmosphere, clouds, and land surface. This is different in different areas, and we'll talk a little bit more about what affects that. But first, let's review. What are the two motions that Earth makes in space? I hope you said the first is rotation, which is how the Earth spins on its axis, and the other is revolution, how the Earth goes around the sun. But if we say the Earth spins on its axis, what exactly is the Earth's axis? An axis is an imaginary line that runs through the center of the Earth, and it is what we rotate around. Earth's axis comes out at the North Poles and the South Poles. And our axis is tilted 23.5 degrees from being straight up and down. This means that we have a tilt of 23.5 degrees. Let's take a look at a simulation. In this simulation, we can watch as the Earth moves around the sun. And what you'll notice is that the axis is always pointed in the same direction, even as the Earth rotates revolves or orbits around the sun. This is important. So if we look at this time of year right here, we're at approximately June 21st. This is called the summer solstice, and it is the longest day of the year. If you'll notice, what causes these conditions is that the northern hemisphere is pointed towards the sun, so it is receiving more direct light from the sun. As we move around throughout the year, when we come to this position, September 21st, this is what we call the fall equinox. We call it the equinox because the day and night are of equal length. The Earth is pointed, the northern hemisphere is pointed neither towards nor away from the sun. As we continue to move, we'll come to December 21st. This in the northern hemisphere is the shortest day of the year, and we call it the winter solstice. If you'll notice, the northern hemisphere is pointed the most directly away from the sun during this time of year. As we continue, we'll reach March 21st. That might even be the day that you're watching this video. This is known as the spring equinox, and on this day, the day and night are equal. Let's go back to our presentation. Let's take another little quiz. Looking at this image, which band of light is carrying the most energy? Is that A, B, or C? This one can be tricky, but I hope you said none of the above. They're all equal. Each of these lights has the same amount of energy, but when B hits the Earth, the light is more direct and less spread out. Even though there's the same amount of energy, the point at B will heat up faster because it is only covering this small area, whereas A is spread out over this very large area. So light at A is at a more of a slant, and it is more spread out. Light at B is more direct and less spread out. In addition, if we look at light B, this ray only passes through a short amount of atmosphere because it passes straight through. At A, because of the angle, it passes through a significant amount of atmosphere before it reaches the Earth. We learned previously that the atmosphere absorbs radiation or energy from the sun. So the more atmosphere that the light passes through, the more energy is absorbed and the less that reaches the surface. So let's do another little quiz. What's wrong with this picture? I hope you said that the Earth isn't tilted. That's better. All right, what season is it at X? I think most of us got that it is summer. What about Y? Here it's winter. What about Z? What season is Z? Think about this for just a moment. You may want to pause the video. Remember, for our seasons, it only matters if we're in the northern or southern hemisphere. Since Z is in the northern hemisphere, it's summer at Z as well, it's just nighttime. In 12 hours, Z will be over here, receiving the most direct sunlight, and it will be summer in the daytime. So what is the reason for the seasons? That would be Earth's tilt. Let's take a look at another simulation. This simulation also shows the sun going around, the Earth going around the sun. And what we can see from this is what it would look like to a person standing on the ground. This shows the direction and angle of the sun at noon on any given day as we move throughout the year. So if this person is standing in the northern hemisphere, about on par with Colorado, at noon, the sun will always be coming from the same direction. But as we pass throughout the year, the angle changes significantly. We call that the angle of insolation. So in January, the sun is shining at a very low angle, and as we come closer to summer, the angle of sunlight is much more direct. So I want us to look for a moment at June 21st. At this date, where is the sun shining most directly? I hope you didn't say the equator, because the rays of light are shining most directly on this latitude right here, which is 23.5 degrees north, and it's known as the Tropic of Cancer. If we look at December 21st, again, the sun's rays are not shining most directly on the equator. They're shining most directly at this line here, which is 23.5 degrees south, or the Tropic of Capricorn. Another interesting feature is, if this person is standing between the Tropics of Cancer and Capricorn, as we move throughout the year, the sunlight, if you look in this box, appears to be coming from different directions at different times during the year. That's something that's unique to this region between the Tropic of Cancer and the Tropic of Capricorn that we call the tropics. Let's take a peek back at our presentation. This image shows what it might look like for a person standing in the center of, just a person standing as they watch across the horizon. This is the sun's path across the sky in the wintertime. It actually starts on this side. This is the sun's path across the sky in the winter. This is the path at the equinoxes, and this is the path at summer. So, what do you notice? We all know that days are shorter in the winter, but why is that? It's not because the sun moves faster. Days are shorter in the winter because the sun has a shorter path across the sky and is lower on the horizon. During the summer, the sun is much higher in the sky and has a much longer path. We call this point when the sun is the very highest in the sky solar noon. Also important to note is that the sun only rises and sets directly in the east and west on the fall and spring equinoxes. At other points in the year, it appears to rise in the southeast and set in the southwest during the winter, and during the summer, it appears to rise in the northeast and set in the northwest. And last but not least, this is to me an interesting diagram that shows how the sun looks at various locations. If we were at the North Pole during the summer, the sun would not set, but would simply make a circle around the sky. That would be fascinating to see. As we move further south, the sun always stays very low on the horizon, but it begins to get higher as we move further south. The middle latitudes are about where Colorado is, so this is about what we see during different times of the year: winter, fall, summer. And here we have the Tropic of Cancer, where the sun is much higher in the sky, and at the equator, where it is the highest in the sky on the equinoxes and makes an interesting path. Between the Tropics of Cancer and the Tropic of Capricorn, during the year, remember, that angle of light changes. So, on the summer solstice, the sun's radiation shines most directly on the Tropic of Capricorn. On the winter solstice, the sun's radiation shines most directly on the Tropic of Wait a minute, I might have said that wrong. On the summer solstice, the sun's radiation shines most directly on the Tropic of Cancer. On the winter solstice, the sun's radiation shines most directly on the Tropic of Capricorn. Between the Tropics of Cancer and Capricorn, the sun will shine from different directions during different parts of the year. I hope that you have enjoyed this presentation and this unit. Thank you for watching.